This lesson describes the arithmetic data types of Java. Java has 9 fundamental data types. Of these, 7 are numeric and can be used for arithmetic. These are the data types that are built into the Java virtual machine and have arithmetic operations defined for them as part of the Java language. The fundamental data types are the building blocks from which all complex data is constructed. The smallest of the arithmetic data types is the byte. It's an 8-bit integer value. It can contain a maximum positive value of 128. Next is the short data type, which is twice the size of a byte and takes up 16 bits. Just like the byte, it's a signed data type, which means it can contain both positive and negative values, and it can contain a maximum value of 32,767. The next data type is the char, or sometimes pronounced char. It's the same size as the short, but it's an unsigned value, with its largest value being 65,535. In fact, this is the only unsigned value in Java, and while you can do arithmetic on it and convert its numeric values to and from the other fundamental data types, it's intended to hold members of the character set of Java. The character set of Java is Unicode. This means that Java character data can be composed of any characters from any alphabet in the world. Every character in every alphabet has a numeric value assigned to it, and that value will fit in a Java char data type. The ASCII character set has its set of numeric values, which range from 0 to 127. To be compatible, the first 127 values of the Unicode character set are the same as the values of the ASCII character set. So, Java can work with ASCII data without any conversion other than from 8-bit character values to 16-bit character values. This size change only comes into play when Java is doing file input or output, so it can usually be ignored altogether. We'll be getting into it later with reading and writing files, but even then it's mostly automated and not much of a bother. Here we have our star. If you had to pick one data type that was more popular than all the others, it would be the int. It seems to be the one that's used most often. It's normally the one we choose for indexes and loop counters for simple arithmetic and to generally keep track of numbers for us. It's a signed 32-bit value. Most computers today are 32-bit machines, so we tend to use 32-bit values without thinking much about it. One really nice thing about a 32-bit integer value is it holds a range large enough to perform most arithmetic operations without running over. Its largest value is 2,147,483,647. The largest of the integer values is the long data type. By the way, the sizes of these fundamental data types don't vary from one machine to the next the way they do in C and C++. In Java, all the data type sizes are fixed. The long data type is a signed integer that takes up 64 bits. This means that the long data type can hold a maximum positive value of 9,223,372,336,854,775,807. This is the data type that's used to contain date and time information. In Java, timestamps are in the form of a count of the number of milliseconds, both positive and negative, from January 1st, 1970, and the span that can be represented goes 250,000 years into the past and into the future. And that's it for the 5 fundamental integer types of Java. In addition to the integer types, Java has 2 real number types. A real number is any number with a decimal point. The first real number data type is called float. It's the smaller of the two and takes up 32 bits of space. This makes it the same size as the int. The 23-bit mantissa provides something just over 6 digits of accuracy, and the exponent can specify large numbers with the decimal point as far as 38 positions to the right and as small as 45 positions to the left. The 32nd bit is the sign bit. The larger floating point format is called double. That's because it's twice the size of a float. It takes the same size in memory as the long does for an integer. The 52-bit mantissa provides an accuracy something just over 16 digits, and the 11-bit exponent can be used to express either a positive exponent as large as 308 or a negative exponent as small as minus 324. The 64th bit is the sign bit. By the way, both the float and the double data types use the IEEE 754 1985 standard format. That's it for the 7 arithmetic types of Java. 5 integer types, 2 real types. With only one exception, every time you see addition, subtraction, multiplication, or division in Java, one or more of the items in this list are involved. That one exception has to do with addition only, and we'll be covering that one shortly.